I would like to introduce you shortly and your companies you're standing for. Thank you very much for coming. And we had already 45 minutes about chemical recycling, 15 minutes about mechanical recycling, and now we have just time, 45 minutes for bio-based plastics and the science behind. So, and I would like to start with you, Belén. I think I pronounced it in a great way.
Very well.
Yeah. Is Monje or Monje? Monje. So, okay. That means it's more the Catalonian way. Okay, good. Belén is from AIMPLAS. AIMPLAS had also a booth here. I think there's a Spanish corner, so where you are. And AIMPLAS is a private technology center based in Valencia, and Monje is a sustainable chemistry cluster leader at AIMPLAS. And AIMPLAS is specialized in the plastics sector and supports companies throughout the entire plastics value chain, from raw material suppliers to processors and end users. So you are, could I say, you're a little bit like Fraunhofer in Spain? So would be,
yes,
yeah?
but smaller.
Yeah. Okay. Good. Yeah. Just to bring in the right frame.
Yeah,
so good to have you here. Thank you very much, and applause to you that you are here. And
thank you very much.
Then we proceed with Thomas. Thomas Philipon is the CEO of a joint venture of TotalEnergies and Corbion. TotalEnergies Corbion, that's a correct name. So it's a joint venture of TotalEnergies and Corbion. That's then giving the name. And the joint venture is known as Corbion, is known for a longer time for being an expert in PLA, polylactic acid bioplastics. And under the brand name Lumini, you sell this, and yesterday I visited your booth. Highly interesting examples. And PLA, for those who do not know yet, I doubt there's somebody who does not know, but let's say it's biodegradable. It's not only bio-based, and from renewable resources like sugar and starch. Yeah? So you need some carbohydrates. So that's great. We will come later to more details in that. And then we move onwards, not only on polymers, but maybe even on chemicals, base chemicals, and to Mathias Leimbrink. He's head of life cycle assessment at Covestro. So if you have a question to LCA at Covestro, he afterwards has 1 hour time to answer all your detailed questions.
At the booth.
At the booth of Covestro. So, no, thank you very much for coming. Also, Thomas, for you, an applause first, and then directly applause also for Matthias for being here. And Covestro, as you said, has a booth here, leading global company specializing in the production of high-performance materials, such as polyurethanes and polycarbonate. And the company is a special one in the plastic and chemical area. Normally, you have the sequence: first is climate neutrality, then circularity is a tool for that. I think if you study Covestro in depth, you find it the opposite way. Covestro puts circularity in the first line and says this is then the way to become also climate neutral in the future. So a nice approach, and one part of that is that some materials should not be fossil anymore, but should go in a kind of circular way, means in the biological circle, and that is the reason for the bio-based material. We will dig later in what are the special ones. Let me start a little bit with the science, Belén. Then, as said, AIMPLAS is a Center for Sustainable Plastics Technology. How does your research contribute to the transformation of the chemical industry towards a more circular economy with polymers? Now we have this is the advertising block now.
Okay,
yeah?
okay.
So.
Thank you very much, Thomas.
Yeah.
It's a pleasure to share this roundtable with Covestro and TotalEnergies Corbion. And for sure, thank you everyone
Please
for
keep the
attending.
micro close to your mouth. Yeah,
Closer?
yeah,
Okay,
yeah.
thank
And
you.
everybody can listen to it.
Okay,
What you say?
okay.
Yeah.
So thank you everyone to attend this roundtable. As you have very well introduced, AIMPLAS is a technological center focused on plastics. We cover the full value chain. So we are located in Valencia, Spain. you are invited, all of us, to visit us here in the stand, but also in Valencia, for sure. And as a technological center, as Thomas has explained, as Fraunhofer, but smaller, we are around 300 people, 300 researchers. We cover the full value chain from the synthesis of polymers, additives, development of compounds, coatings, the processing of these materials, and the end of life, for sure. So in the framework of a circular economy approaches, which are our key drivers in our main research lines, we cover all these developments, all this value chain, and we consider from the beginning that after and before, basically we have to start in the co-design concept, considering which are the best solutions for the final requirements, but not only considering the high performance of these materials, but also the end of life of these materials. So to this aim, we evaluate and we consider that we have to get as much data as possible. And for this reason, we evaluate the techno-economic feasibility, and we perform LCA assessments, etc., from the very beginning, before starting a new development, because we consider that it makes no sense to start in a new development of a new material if we are not considering this, as we have seen in the previous roundtables. Is very relevant because we can talk about mechanical recycling, chemical recycling. It's better to produce a bioplastic. That is something that we are going to consider here. We have to make and to achieve data from all these strategies. Maybe it's depending on a lot of each one of the applications, each one of the strategies, our business models. We have to evaluate which is the best one. So for this reason, we count with different full equipped laboratories, and also more than 50 pilot plans in which we could achieve to evaluate and to get this data with which we could evaluate if the scalability, if the industrialization of these developments, it makes sense or not, and which strategy is the more circular one.
Thank you very much. Yeah. So we move to you, Thomas, and the PLA mass market, because the startup times of Corbion are really in the deep past, and you would like to conquer the mass market. What is, of course, with bio-based PLA? Is there also, by the way, is there also not from you, but from others, fossil PLA in the market, or is all PLA what I see is it's mainly bio-based?
No, that would be an interesting innovation that I don't know of, right?
Yeah. Okay.
No, as far as I'm concerned and as I know, I think PLA is 100% bio-based for everybody, including us. Mm-hmm. Maybe what is also interesting to know for people that maybe don't know much about the biopolymers is that the type of product we carry, PLA, can be depending on the formulation, but it can be also composted, mechanically recycled, and chemically recycled. So depending on the formulation, you can have access to different end of life. So that's the end of life value proposition. For the start of life value proposition, it's pretty easy to explain, even for people maybe not in the plastic industry. We start the biopolymer with basically capturing the CO2 from the atmosphere to grow the plant. It's the same as the one that you have at home. So you take the CO2 from the atmosphere, we do our wonderful job of polymerization, and then basically we try to be very frugal about the CO2, and we get into an LCA, which is a common trait between us, which is very positive at the end of the day for us, but also, I guess, for the industry. We can pledge to have 85% saving in the carbon footprint compared to the conventional plastic. So I think that is really important from a value proposition. Start of life, the end of life, which is very versatile, but at the end, the LCA is very positive compared to the product we try to replace and the solution we bring to the market. Mm-hmm. So this is really important to know about the PLA and the biopolymer in general.
Yeah, what can stop PLA to be the mass market polymer of the future and maybe replacing other polymers? Those who from other companies don't listen now, but what is your... Is this possible, or we know also in all plastics have very, very specific properties, and that's even the upside of plastics, that for every purpose you have a different one. Is there a larger field of application for PLA than at the time being? What would you say? And yeah.
So this is a very interesting question, especially coming from a plastic expert. We all understand how plastic works, and there is not a magic plastic, unfortunately, which could replace everything. Guess what? It's also not working for biopolymers, so I'm afraid to deceive you there. Having said that, we have a different type of application with PLA, and we are more in the category of a polyester. But depending on the application, sometimes we would replace applications which are done with PP, with PS, with PET. It would depend really on what you're trying to replace. The main application today are more into the food serviceware, the plates, the spoons, and the straws, but those ones are really from the past. We are now moving up to a different type of application. If you come to our booth, you will see a super nice 3D printing machine, and PLA is actually the standard in the industry. So this is really one of the big applications today. Obviously, our job is to push the boundaries. So we have also application now in non-woven. So we can do an air filter, which used to be basically non-woven PP. Now you can do it in PLA, having also a different end of life. We are also looking at fibers. We can do a cloth with that, but we're even pushing even more the boundaries. And we have just developed, and this is different from the competition, an expanded PLA. So we can replace EPS with what we call EPLA. I know it's maybe not super very creative as a name, but we do have EPLA to replace the EPS. So we continue to push, and we are developing also compounds. We have application in the automotive industry. So I'm not going to give you all the application, but what I can really promise you, if you have heard about PLA, if you know where it was used, forget about that, because now we have moved on, and we can do much more things with PLA. And at the end of the day is to bring this value proposition I described to you earlier to different applications. So it's not going to be the polymer for the future. Unfortunately, it cannot replace everything, but it can really push boundaries in many different applications, and we are very busy doing that.
Okay, thank you very much. Pushing boundaries, I think this is the key word that brings us directly to Mathias and Covestro. As said, circular economy is in line number one, and one tool or one measure to achieve this is you include bioplastics in your strategy, but also biomass-based chemicals. And there's one recent initiative I think that you have in mind, and please tell us about this a little bit more in detail.
Yeah, exactly.
This microphone is not open, otherwise you take your microphone from your neighbor.
Okay.
Now it works. Okay,
now it works,
good.
okay. Yeah, exactly. So, and I'm also happy about the consequence of the panel talks today, because also chemical recycling and mechanical recycling are super important for Covestro. But since we heard already a lot about that, I'm happy to talk you through that at our booth about these topics. But today or now it's about bioplastics and bio-based solutions. And yeah, in Covestro, we are developing one flagship solution, which is our bioaniline. Aniline is a major precursor, or the most important precursor that goes into MDI, one of the polyurethane ingredients we are selling. And yeah, that is an ongoing development where we are able to currently run it at a pilot scale to be able to continuously produce bioaniline that at one point in time will replace fossil aniline in our productions. Besides that, we already have since decades bio-based feedstocks that we procure from companies like Corbion and integrate that into our portfolio. And that is, of course, an ever-increasing share of our portfolio that is switched from fossil feedstock to bio-based feedstock.
Mm-hmm. As you are the expert for LCAs, I dare to ask the question, what around is the benefit in CO2 footprint if I use a precursor bioaniline instead of fossil-based aniline if it comes to MDI?
Yeah, as an LCA expert, I have to tell you it depends. Yeah. So,
any lawyers here?
No, I mean it really depends. It really depends on the feedstock you're using, on the processes you're running it.
Yeah.
So it really depends. However, as already explained beforehand, usually biogenic feedstock have the huge advantage that they have removed CO2 from the atmosphere that you are able to claim on a product level as a carbon footprint reduction. Yeah? But how large this production is depends on the molecule, what else is needed to produce this kind of molecule, and also the biogenic feedstock you're using. Is it first generation, second generation, and so on? Yeah? Is it maybe a waste product? Then it's more favorable. So it really depends. There are tons of variations you could have.
That sounds that technology-wise, you and Covestro are quite ready. The question is, what has to happen that this is also successful in the market at the end, or the products that are made from those bio-based precursors are successful in the market?
I think we heard it before. Yeah, I mean, regulation is one obvious topic that could help, and where we are actively advocating for it. But in general, I think in the end, it will come down to economics, and such processes are in the beginning usually more expensive, and especially with bioaniline, we are also still in the pilot scale. So it's not that it's a commercialized solution yet. So we are still validating the technology we have. We are still optimizing in order to make it really, fully scalable at some point in time. But that depends a bit. Yeah.
I learned that world market is around about 6 million tons of aniline, and Covestro is about 1 million, with about 1 million tons. So that is a big portion in that market. Of course, you do. I think do you have plans ready when you say these are fully aniline? I would doubt that this is like an early stage, maybe not yet.
Yeah.
But do we have a long-term view on in which direction you would go with this and other bio-based chemicals?
No, absolutely. I mean, as I said before, it's complementing our efforts in mechanical and chemical recycling. In parallel, we are also advocating and pushing forward the mass balance approach in Covestro. So in total, these are different levers we're gonna use in order to become fully circular in the future. And I mean, we will definitely move away from the fossil resources, but I would not say that we would replace all our 1 million tons of aniline with bio-based aniline. That I think will not gonna happen, but it will be a complementing part in making our company more sustainable. That's for sure, yeah.
Okay, so moving to you, Belén, again, and the scientific or research part of the topic. I think you have the intention at AIMPLAS to create safe and sustainable strategies or products by design. So what is behind that? What is in connection with bio-based products?
From our point of view, is very close, and there are a very close connection, because of course, as you know, the safe and sustainable by design has to consider the intrinsic properties, the hazardous properties of the materials, of the raw materials that we are using. In this sense, we select of course, substances that are safer. We are not going to use substance of concern or some substances that could put any obstacles in terms of the REACH regulation or other regulations in terms of the safety of these materials. And we consider that bio-based materials, if true that we could consider bioplastics as bio-based or biodegradable materials, if we are talking of bio-based materials, of course we have to consider that we have this benefit of the CO2, the reduction of these emissions and this use, but we have to consider that basically the monomers that we are using to produce these bio-based materials, bioplastics, are based on the avoidance of the use of hazardous substances. It's true that there is some people sometimes that is confusing bio-based with the safety. It's true that it's not aligned, but of course it's something that in the main players in the big industry related with the development of these bioplastics, these bio-based materials are considering this safety too. Sometimes we can hear that we are going to produce a bio-based bisphenol A. For me, it's something that is a bit complex to understand. I know that the bisphenol A is used for some applications in the market today still, but it's true that from a point of view, it makes more sense. And in AIMPLAS, we consider that these bio-based raw materials have to be, of course, avoiding any hazardous. And in this term, also for this reason, we have been working for many years with many collaborators, companies, industry members in the development of bio-based materials, in the use of CO2, capture of CO2, and in the use of this CO2 to produce a polycarbonate, avoiding the use of bisphenol A, for example, or to produce a polyurethane, a non-isocyanate polyurethane, in this case, avoiding the use of an isocyanate that it makes. And it provides these hazardous properties at the end of their life. And for sure, considering with these LCA tools and the end of the life. So in this term, we try to incorporate as much recycled material as possible. In all the developments, we try to incorporate as much renewable sources, so bio-based and biodegradable products as possible, and we are developing this type of strategies.
Okay, yeah. So then we move back to PLA, and Thomas, you have Corbion runs a plant in Thailand with around about 75,000 tons.
TotalEnergies
metric
Corbion.
tons annual output, one of the largest in the world. Where do you plan further capacities?
Yeah, I must also tell you that biopolymer is like the other polymers, right? So when you try to plan basically for a new plant, what you try to think is about where the feedstock is, where the demand is, and can I make money with it, right? So
Yeah,
I think
absolutely.
it's so we just having exactly the same type of analysis. So I can just help you a bit with some answers to those questions. The first one is about the feedstock. I think we have mentioned that some of our competitors are using corn as a feedstock. That's possible. Personally, as a company, we're using the sugar of the sugar cane. You can have basically technology using the beet. You can use wheat. So this is really one of the advantages of the PLA, that to create the lactic acid, you would use basically the feedstock, which is in abundance where you want to make it, right? So that's one. So from a region standpoint, you could be quite versatile where to put it.
Yeah.
Then from a demand, I think I must also inform you that the main growth area is not Europe for biopolymer, but it's more in Asia. So that's giving you also an order of magnitude where it could be the first on the next plant, or for me, but also for competition. And the other thing which is really important is to continue to make money with it and to be able to bring basically a solution which helping us to continue to drive growth. But it's also something that would help our customers and the whole value chain to continue to create basically value. Because at the end of the day, you're in biopolymer, you're in conventional plastic, it's the same story. You want to create basically value with the partners that you have, right? So definitely, I think you will see more PLA plant coming. Some are already being built in the regions I mentioned, by the way. We will also consider to continue to bring growth to the equation, but also maybe for the audience to kind of direct you to the order of magnitude of what we are talking about. Biopolymer today is 1% of the annual consumption of plastic. If you're thinking about the 400 million tons, think about biopolymer in total, about 1% of that. So indeed, when you're talking about replacing, application by application, cycle by cycle, we do have a lot to replace. Even if the overall market is not growing, you still have quite a bit of replacement to do and quite some job for us to be on, right? So this is definitely going to continue. So through that growth, you will see more and more capacity being built, more and more solution being also put together, and more value to be created here.
Yeah, but that brings me to the next question concerning PLA. So then normally we have here maybe a prejudice that Asia is not the front runner in sustainability, and Asia is not paying higher prices, maybe even lower prices than Europe, for example, for a certain material. Having this in mind, what is so different in Asia and so positive for PLA? What is not yet the situation in Europe?
No, that's a very good point. As we all understand, biopolymer, PLA in particular, are the new kids on the block, right? So we have not went through the curve, right? I think about PET, when it was invented, 1950. Today it's a standard for a plastic bottle, but that's basically 70 years in order to get there. So PLA just started around 2000, so we're still this guy, right? So in order for us to grow, we continue to have some help from the market creation. What I mean there is legislation. So to get and to bridge to your questions, why it's working so well, especially in China, is pretty simple in a way. There was a specific mandate to say by 2060 we'll be carbon neutral. And they turn around and ask the industry to say, look, what can you do to help me to get there? And then the industry is organizing themselves. It could be anywhere. We organize ourselves and we bring solutions. And this is moving. You have other example, which is a bit closer to us, that for example, in Italy, they have made basically a certain ecosystem, which is helping to use plastic, which will be biodegradable. So they organize a whole value chain saying, if you have a biodegradable, certified biodegradable and compostable items, you can use the organic waste. That is also by legislation. So that this type of tools, being the Chinese one or the Italian one, are really important, especially for those new material. They have to develop themselves, so it goes through the innovation cycle, which is the same as the other innovation cycle in any other polymers, but also to help to create this value and help us to continue to bring solutions. So this is really about the ecosystem and the legislation. This is really important, especially for biopolymer.
Okay. Yeah, that's interesting because I think some people in Europe would underline that European regulation is the most advanced against the Green Deal and things like that. Obviously, not for every element of a circular economy. Thank you very much for your insights here. And then that leads me in general to the topic of biomass. So I visited 3 months ago a farm, and I asked the farmer, do you have some residues? So do you have some waste on your farm? And he said, I never have waste. My father has not had waste, and my grandfather had also no waste. So the question is, if we want to go more in biomass, a question to all of you, so we will let you all come to an answer. If we move a little bit more, then biomass as a resource, is there enough biomass? And I'm not talking about only also secondary biomass, not only primary biomass. Is there enough biomass to make this move in, let's say, more than 1% of the polymers and more than 1% of other stuff that is derived today from biomass? And what has to happen and where we have to look at to do that? And I would like to start with you, Matthias, because you have even the broader spectrum, not only polymers, but also basic materials in that direction. What is your perspective on that?
Yeah, so that is definitely a very important question to be answered, and we are in continuously discussions with, and I saw that he will be on stage here later, Michael Karus from the Nova Institute, and I think there is reliable research that most likely in 2050, 20% of the carbon for the chemical industry will come or needs to come from biogenic sources, the rest then from recycling most likely, and CO2. But 20% will come from biogenic sources, or have to come from biogenic sources. And of course, we are in many discussions with all the big suppliers of dextrose, sucrose, whatever is needed to run the fermentation process. And also they are, to my also surprise, they are quite relaxed about that. Yeah, so they think, our whole society is becoming more aware about a healthy lifestyle. So there are less and less soft drinks that are sold where usually the glucose is produced for. So it's kind of, they are not having, we don't have enough for you. It's more, if you want, you can have it, right? So it's, I think it's a promising direction. It's not said that there is right away enough for the entire chemical industry, but if we have such pilot systems like our bioaniline, and I'm pretty sure there are much more others, I think that's definitely doable, and it will be scaled up with the agriculture, I would say, and also according to the Nova Institute, and I think that is quite encouraging. It only needs like a 10% yield increase for the agriculture to really be able to serve this entire demand from the chemical industry. So, yeah, it is a challenge, but I would say it's there is a light at the end of the tunnel, and to me it's more promising than actually an obstacle.
Thank you very much. I would like to go the line backwards. Thomas, what's your answer to that?
No, this is a question we got a lot, right? I mean, I agree with you. We need to tackle it. You know, it's not something that you can avoid. And what we do, I'm engineer by training. What I like is also to use data or to use facts, right? Because otherwise we just have an advice, and maybe it's good or bad. But let's look at the number, right? So. We love also to work with Nova Institute, which is really a third party. They have very good numbers, right? So what you look is basically the problem is in all this discussion most of the time is do we have enough space in order to have, do we have enough arable land in order to grow everything? Okay, let's look at where do we use that arable land. Most of the time is to grow food and feed and a bit for the rest, yeah? What is the percentage of the food which is really getting into the plate of somebody globally? There is about 1/3 which never see a plate, you know? So there is 1/3 basically of the food which been grown, used arable land, we never get into anybody's plate. So there is basically something there that to think about.
Because it gets wasted.
It gets wasted.
Not treated in the right way.
Exactly, or it did not get consumed. Yeah, so that's one part of the equation. What's happening with this waste? It gets most of the time in landfill. When they are in landfill, what do? No, they try to decompose to methane, right? What is the impact of that? It's about 10% of the greenhouse gas emission. Okay, 10. What does it represent for a normal being like us? It's about the same as the exhaust of all the cars and the truck on the streets everywhere in the globe. So we are talking about big number here, right? So. I'm not saying that we should look somewhere else. I'm just saying let's look at everything and let's also take the right actions. Going back to the biopolymer today, in order to basically produce this biopolymer, the famous 1% that I'm talking about, and I'm using the same number as you from Nova Institute, it's 0.013% of the arable land. 0.13%. So that's not a great deal, right? Let's do
the time being or in the future? Today.
So we're looking now, exactly, I'm getting there. Thanks, Thomas, for the transition. That's appreciated. Visionary, that was the title. So, okay, we are here. I will take even another comment, which would be even more aggressive. I would say we'll do the best job we can. So we'll continue to grow at 10-15% year on year, which is also documented number. Okay, how much we will consume in 2023? 0.03%. Okay. Okay. So now I will stop here and say, okay, what do we want to do? Do we have really a problem with that? That's the first part of the answer. The second one is about us as an industry. Are we going to stand still and continue to use basically a certain feedstock? Guess what? No. We'll continue to work, and the second generation is already there. Guess what? It's not effective. Okay, we don't like that, so we'll continue to work on it, and we'll create basically new routes. And the second generation will come, and it will be even more effective. So I think there is really issues. We should talk about it, but we should really take the value where it is. And today you have solutions. Let's use them.
Very good. Thank you very much. The question is also to you, Belén.
Okay, thank you.
And you please think about your question afterwards. The round is then open to you. So, Belén.
Yes, basically in the same sense, I totally agree with.
Thank you.
We have also the same figures. We have evaluated that according to these studies, in the future, not today, in the future, maybe in the mid-century, we will require from biomass around 40-60 exajoules per year. According to the energy transition energy calculations, estimations, and in this sense, this at 20% of the biomass could be used for the development of materials and maybe also SAF. This is maybe the competitor according to this information, but of course, these are the prioritization materials. We have to prioritize the use of this biomass to these bio-based materials because there is no other alternatives that it will. It's true that with the circular economic approaches, with this recycled content in the materials, with the mechanical and the chemical recycling, of course, it will contribute to reach this 20% of the total. But we consider that we could cover it. We are optimistic, but everything and everyone has to be aligned. The policymakers, the regulatory and standardization bodies, the researchers and the industry to be aligned to reach and to demonstrate a strong commitment and responsibility.
Thank you. So any question to the bioplastics and experts from industry and research? That is not the case. So